Good morning. Today we'll be talking about enzymes. Now, what is an enzyme? An enzyme is a three-dimensional protein which functions as a catalyst. What is a catalyst, you will now ask? A catalyst is anything that helps us to speed up a reaction. Now, in this definition, the two things are extremely important. One, that it speeds up a chemical reaction, and number two, that it is not changed by the reaction. It remains unchanged at the end of the reaction. And enzymes are used in extremely small quantities in the reaction. They are not used up in the reaction. So in a reaction proceeds, for example, that a reactant reacts with a substrate to form a product. So the enzyme will help the substrate to reach the product. How enzymes work, we will study in detail in chemistry. However, if you want to know the concept is that the enzymes help to lower the activation energy required for the reaction to progress. Now, for the purpose of biology, we will be sticking to the biological properties of enzymes. All enzymes are protein in nature. If we come to the pharmacokinetics of enzymes, and how enzymes work is that each enzyme has an optimum temperature at which it has its greatest react activity. As the temperature is increased up to 40 degrees, the rate of enzyme is also increased. The optimum temperature in the human body is 37 degrees Celsius, which means that the rate of reaction of most enzymes is optimum at 37 degrees, after which the enzyme becomes denatured. Now, what is denaturation? Denaturation is the permanent irreversible. You need to focus on the two things I have said right now, permanent and irreversible. It is the permanent irreversible change in shape of an enzyme. That is denaturation. Now, in the human body, there are different enzymes. Enzymes are present all across the human body, in the stomach, in the intestines, in the pancreas, in the human liver, everywhere. So, what do enzymes do? They help us in the digestion of food. This is the basic chapter. This will help us to link the chapters which will come in the following chapters. Now, in the stomach, the optimum pH of the stomach is 1.5, which is an acidic pH. So the enzymes will have their maximum activity at a pH of 1.5. Examples of enzymes which work in the stomach are, for example, pepsin. Pepsin breaks down the protease into amino acids. Similarly, enzymes in the small intestine have an alkaline pH. So the optimum pH varies for different enzymes. In the small intestine, the enzyme tryptase breaks down trypsin into amino acids. Now we will be looking about how enzymes work. The most important theory is the lock and key hypothesis. It states that the enzyme is the lock and the substrate is the key. Just imagine a lock and a key. So without the key, this lock cannot be opened. Similarly, in the lock is the active site, the active site is present on the enzyme. You need to remember this in many questions in past papers. They have asked whether the active site is present on the enzyme or the substrate. So the active site is always present on the enzyme. It is never present on the substrate. Here is a better diagram. Look, this is the active site on the enzyme, and this is the substrate. The substrate is the key, so it has an identical share. It has an identical shape to the active site, so it can just fit in and break down into the products. This is normal. Now in this figure, this is before the reaction has occurred. This is after the reaction occurs. So this enzyme substrate complex is formed, and these are the products which are formed. Now what happens is in denaturation that the shape of this active site is changed in such a way that when the substrate tries to fit into the active site, its substrate cannot fit in, the key cannot fit in because the shape of the two have been denatured, the active site has been denatured. Now here is just a brief summary of the top of the things we revised in the previous video and in this video. I talked to you about diffusion and osmosis, what factor transport means, and we discussed turgor and water potential as well. Thank you.